Yes, sir.
And by the way, in that Monday class, Thiru, can you attend the morning class on Monday
Yeah.
since you
What?
have off?
Yeah, yeah, sure.
Okay,
Even I can, sir.
okay. It will be better for you also. And
I'm
Thiru,
done with this.
okay, Thiru, are you done solving with that question? The
Yeah,
examination.
almost done with that. Yeah.
Acha, fine, good. Now,
So,
okay.
I wasn't done with that. So,
Oh, okay, right. So tell me once done.
yeah. So, are you going to college to the center?
On Monday,
No, no, I'm just asking in general.
it's not necessary for these chapters. Although
Oh.
if you want to come, let me know. I will schedule a class that way.
No, I mean, if it's required, then sure. But
Wait for quantum, and next is
like, can
nuclear.
we revise like all the practical subjects once?
Revise all subjects.
Like, I mean, all the practical topics which require an offline class because some
Yes,
of them are taken online, right?
of course, of course. So that's why let's quickly finish the last four chapters and then we will revise all the practical topics.
Now, I was wondering if you could do it within like this, within this week or next week because I have vacations, right? So I'll have a bit time.
Okay, so let Raken also come back. He is not here,
Yeah,
and I need to check with Jidai as well. So fine, I'll get back to you.
that's it. Then.
Great. All right. So now, Raken, please read this out. What is this equation?
Energy of incident light is equal to the work function plus kinetic energy of emitted electrons.
So
That's
wait. So basically, this is energy conservation. Incoming energy is energy of incident light. That
right.
is used to do two things. One, to eject the electron, which is the work function. Once the electron is ejected, the remaining energy is kinetic energy of the emitted electron. Does that make sense? Okay.
Yeah. What?
So that's it. Uske baad we write down the equations. HF is equal to HF naught plus half mv square. That's what we call the photoelectric equation. Write this down. Oh, sorry.
So you can find the F naught using this.
Yes. And do either of you know the real world applications of this photoelectric effect? Where is this possibly required? Ejection of electrons.
Light emitting diode,
Light on, light emitting
LDR.
diode. Again, go very uh, close to home. What devices we have which use this
Phones.
principle? Phones, yes. How exactly, Rakin?
Charging or
True. See, some phones have this feature that depending upon the surrounding light, they increase or decrease the brightness,
brightness. Yeah,
right?
yeah.
So that is this principle at play.
Oh, okay.
Most
So where's
phones
it
have that.
used? Sorry.
So most phones, Thiru, have this feature. If you, it is disabled most of the times, but if you enable it, what happens is the phones have this power to either increase or decrease the brightness of
Your
the
phone
phone
does that. Yeah.
Oh
depending
yeah.
on the environment light. That is this effect.
But when the electrons are ejected, what happens to like the surrounding?
What happens
Does
to
it
the
get
surroundings? Which
does it get
surroundings?
ejected? Like does it get ionized? Like I mean like the photoelectrons are ejected right to the environment.
Huh?
So what
Okay, no, no,
happened?
no, no. So wait, the electrons don't go anywhere. So imagine this is your cell phone, for example. Let's say the light comes in and it goes inside and the electrons are ejected, right? They do not go into the air because the electrons are still in the phones. But what happens is electrons hit a particular sensor. So let's say if you have more light means more electrons coming in. So it hits a sensor. So the sensor tells the phone that it is having more light. So it decreases the brightness of the phone. Does it make sense, Dhiru?
Yeah. So it comes back, right, to the
Of
surface.
course, of course. Electrons cannot leave the phone setup.
So once it's ejected, it comes back.
So imagine like this, when the electron is ejected,
Uh-huh.
it hits a particular light sensor, and that sensor is a reading meter for the phone. More light means more electrons, so then the phone will decrease the brightness.
Okay.
Okay, so this is, we have the Einstein's photoelectric equation. Now moving ahead. Okay, so now graph of kinetic energy versus frequency. Now, Thiru, you have gone through the notes. Tell me, how does this graph look like?
It's like this, right?
But how do we draw it? I mean, what's the mathematical way to do it?
Like this
No, this is not right. Not at all. Look at the y-axis. Y-axis is kinetic energy, x-axis is frequency.
frequency.
So what will the graph look like?
So as the kinetic energy increases, the frequency should also increase.
Do one thing. Can you make K kinetic energy as the subject from this equation? So what will you get?
HF minus HF naught.
Theta, yeah.
And then what kind of equation or what kind of curve will we have? A parabola, a straight line, or what? What kind? How do we check?
Mhm.
Yes, Rakan?
I'm thinking, how do we determine that?
So what is the y-axis? It is kinetic
Kinetic
energy.
energy, right?
X-axis is frequency. So first step, write half mv square as k and write k is hf minus hf naught. Write it down. Done.
Yeah.
Yep.
So now, Thiru, can you guess from that equation what could be the shape? Parabola,
Just straight
I
line.
guess, but how and why?
So K is equal to HF minus HF naught, right?
Mhm.
HF naught is the y-intercept
Awesome.
and F
HF
is the
naught is
x,
the,
right?
okay, let's check. K is equal to HF minus HF naught. So we are going to compare this with the standard equation of a line. Y is equal to mx plus c. So yes, Thiru, you were right. HF naught, not exactly HF naught, Thiru, minus HF
Minus
naught
HF naught.
is the y-intercept. And
Acha,
what is the
हाँ,
gradient?
H.
Yes, that's why. Look at
It will
this.
be like this, right?
Yes, correct. Right. So delete this. And this is the, draw this entire thing. So the gradient is h and the y-intercept is called the work function, which is hf naught. So work function will be hf naught and ft is the threshold frequency.
So how is that the work function?
Work function is what? Hf naught, isn't it?
Yes, so how is HF not below frequency, the threshold frequency?
Wait, in this y-intercept, is it negative or positive?
Negative.
So that's why the y-intercept needs to go below the x-axis.
But
Okay,
how
I
is
got your
this
point. So
working?
work function is positive. It is hf naught. It is a positive value, but because of the minus sign, the graph goes below. Okay, wait, elaborate your doubt one more time, Thiru.
I'm saying threshold. Okay. You said that below threshold frequency, no photoelectrons are emitted, right?
Exactly,
So
correct.
below threshold frequency, which are
Acha, okay. No, no. Below threshold frequency, you do not have any graph. That's why I have drawn a dotted line.
so
The
how
graph
would this
starts.
work function? This this should
No,
be
no,
work
no. See,
function, right?
wait. How come? If you look at
Because
this equation, how do you find this particular point? What is the y coordinate here, Thiru?
kinetic energy
What's the value of the y coordinate here?
zero.
It is 0. So if you put k
0.
as 0 here, you will get f is equal to f naught.
Hmm.
F
Yep.
is equal to f naught, which is your threshold frequency. Isn't it, Thiru?
Yeah.
To get the work function is hf naught. That's your y-intercept. But wait, the graph is starting from this point only, the solid
Yeah,
line.
graph is starting from that point. Then the work function should also start from that point, right? Why is it starting from the y-intercept?
Okay. So didn't we do this, Thiru? What is the y-intercept? It is negative hf naught. Yes or no?
No, no, I understand that, but the definition of work function states that it's the minimum energy of a
It's,
photon
oh,
required,
okay,
right?
understood. It's the minimum energy required, right? And but
Yeah.
y-axis is not that energy. This is kinetic energy of photoelectrons. So
So the
okay,
kinetic energy
Thiru,
is
wait,
supplied.
wait. Thiru, work function is the minimum energy of the incident light. In this case, y-axis is energy of photoelectrons. Two different energies we are dealing with. So
Okay.
energy of incident light will give you work function. In this case, it's the energy of photoelectrons. Still not making sense, Thiru?
No, 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 I understand.
So draw this entire graph. Right, Rakin, done.
No, sir, doing.
Tell me once done.
Yeah, so
This
then.
graph will be constant, right? For the,
Constant as in constant gradient.
yeah, I mean for like, while actually solving questions, the graph will be of KE versus frequency would be the same, right?
Same as in same for what?